even when we're dealing with binomial denominators like these ones here, if I want to get rid of that embedded fraction of divide by x minus 1, divide by x minus 1, what I can do is I can multiply the top by x minus 1. And that will undo the times here, but that by itself will unbalance my original fraction. So as long as I keep the ratio the same, times by x minus 1 on the bottom, I've kept the original fractional value, and I can just distribute across into this and cancel out this divide with this multiplication, this divide with this multiplication. So we end up with x squared minus x minus, and then the x minus 1's cancel, and we're just left with 4. Here we're going to end up with x squared minus x, and then the x minus 1's cancel, so we're left with plus 6. Okay, now these end up being not factorable, so we're going to leave it just like that. We should state some restrictions here. So x is not equal to, this is divide by x minus 1, so we should let that x not be equal to 1. We also have this not equal to 1 here, so we should state that, and I'm not going to be too picky, but we can just say that x is not equal to negative 6 over x minus 1. Okay, and that would be good enough. We're not going to get too complicated with that. This could also be expressed as not equal to, this is, sorry, I can rewrite this exact same thing, and if you just rearrange this algebraically, we will end up with x squared minus x plus 6 not equal to 0, and notice that that's essentially the denominator that we're left with here. Okay, so we have, as long as we have those two restrictions, we don't have to state this one. This one could be stated in this way as well, just stating that restriction there. That would be good enough. So even when we have a binomial, two different denominators, really I just want to get rid of this divide and this divide. Well, I can get rid of both divides by multiplying by the lowest common denominator. If I multiply the top by that factor, those two factors, and the bottom by those two factors, again, I don't change the value of the fraction, so I keep the fraction balanced, which is fine, but it's going to allow me to cancel that divide by m plus 3 with that times m plus 3, this divide m plus 3 with this times n minus 4 with this times m minus 4. So I'm going to do this in a few more steps. So I'm just going to distribute the first part, 3 times m plus 3 n minus 4 plus the m plus 3's cancel. So I'm going to be left with 8, but I still have the n minus 4 factor in the numerator. But I have gotten rid of that extra divide. So here I have m plus 3, m minus 4 times 1, plus the 2, the m minus 4's cancel, but I'm still left with that extra m plus 3 factor that I have to account for. Okay. Now we should expand and combine like terms. So here I'm going to end up with 3m squared minus m minus 12 plus 8m minus 32. This is going to be m squared minus m minus 12 plus 2m plus 6. Okay, then combine like terms. So I end up with 3m squared minus 3m plus 8m is plus 5m, minus 36 minus 32 is minus 68. Okay. In the denominator, I have m squared plus 1m minus 6. Okay. Now we should check to see if this is factorable. The denominator is factorable. The numerator I suspect is not, but we should just double check. Okay. So I'm just going to factor the denominator because it is easily factorable. The numerator is not easily factorable. but it probably doesn't factor. So we multiply those together. I'm going to end up with negative 200 and that looks like 212. Okay, so 3 times 60 is negative 180. 3 times 8 is 32. 180 plus 32 is 212. Okay, so that's going to be 212. And we need to find numbers that multiply to 212 that differ by 5. And I'm pretty sure those don't exist. Okay, so factors of 212 that are a little bit close together might be, what would it be? 4 times 53. Okay, yeah, 53 is a prime number, so we're not going to get very many factors out of that. Oh, sorry, that's going to be 4 times 53. Okay, and that won't. We're not going to get too many other factors out of that. So this is prime, so we're just going to leave that as 3m squared plus 5m minus 68. Okay, so just bear in mind that this particular quadratic is not something that is easily factorable, so this would be more of a challenge type problem, but you should know how to have some strategies to be able to factor quadratics with leading coefficients of 3. Okay, I did forget to state my restrictions, but my restrictions here. Okay, I can't have m cannot equal to negative 3, positive 4, and we should say that 1 is not equal to negative 2 over m minus 4. Now you can rearrange that and solve for m if you like, okay, but this is good enough. Well, I'm not going to expect to get more complicated than this. If you are keen, you could solve for m and say that m is not equal to 2. Okay, and that would be another way to write the same restriction.